Hello everybody. Today I want to talk a little bit about forces. Now what is force? Force is a vector, meaning that it has magnitude and acceleration, right? So like we normally denote force with the letter F, right? When we go through future videos and everything, we're gonna see that this is equal to like mass times acceleration. But one thing I really want to like stress the importance of is units, okay? So force is given in units of kilograms, meters per second squared. I know this because I know that the formula for force is equal to mass times acceleration. That's given by the first law that Newton developed, right? Mass is given in kilograms, and these are SI units, right? Meters per second squared are units of acceleration. So just keep that in mind. This is also referred to as a Newton. So this whole unit right here, this whole term right here can be summed up as a Newton. So if you see 1 Newton, it's 1 kilogram meter per second squared. So that's just because like Isaac Newton was so revolutionary in terms of like forces and everything that we decided to give him his own unit. I don't know if he's the one that decided to give himself his own unit. I don't know. Let's talk about gravity. So gravity is an attractive force, right? Gravity is what keeps us pulled down toward the earth. There's acceleration that becomes due to gravity. If all the air we're taking, if we somehow didn't need air to breathe, and we had like no air resistance and no, because like air molecules sort of slow down our fall, right? If we didn't have those air molecules, we'd fall at about 9.81 meters per second, and that's the gravitational constant that you're gonna see. A lot of people estimate it as like 10. It depends. Like if you got to do it in your head, maybe that might be a good estimate. But like if you're trying to like get to the moon, like you might overshoot the moon if you have like 10 meters per second. That's okay. Meters per second squared, but that's okay. There's a gravitational force that we need to take into account. It's good to remember this formula. F is given by G m1 m2 over r squared. Now this G is a gravitational constant. It's a constant. You just need to remember that G. It's don't worry about it right now. Honestly, maybe if we tackle the question, I'll give it to you. M1 and M2 are the bodies that we're dealing with. So maybe like the Earth and the Moon, if we want to find out the force between them, that's how it's gonna be. It's the mass of our first object and then the mass of our second object over the distance between them. So like, and I believe we're supposed to take the distance from the radius. So if I had 2 objects, I would measure to the radius of each object. That would be my R. So I would square that, right? Cool. Friction. Let's talk about friction. Friction is it's the tough force. Let me say, when I say tough, it's just trying to be difficult all the time, right? It opposes whatever direction you're going in. So if I'm pushing an object this way, friction is acting this way. If I'm pulling it this way, friction is acting that way, right? So if I have an object moving, right, and I'm pulling it this way or pushing it that way, friction is acting in that direction. So there's a friction coefficient that we have to take into account. So we have different types, like there's static friction as well as kinetic friction. If you ever tried to push like a couch, right, and you see that like at first it's a little bit hard to push and then it starts moving a little bit more easily, right? We switch from static, when it's still, because it's static, to kinetic friction, right? There's still friction acting on that object when it's moving, but it just becomes a little bit easier to push. And that's why your coefficient of static friction is normally going to be bigger than your coefficient of kinetic friction. And these are just coefficients that we multiply our forces by to determine what our frictional force is. So that being said, I can say that force, no, I'll do it in green for formula. My force, where's my green marker? My force is going to be equal to my, I'll do this actually. I'll say that, here's what you can say. Sorry. Static. There we go. So like now, right, what does that mean? And sorry, this should be less than or equal to. So basically, my static force can be greater than my frictional force due to static is going to be less than or equal to my coefficient of static friction multiplied by my n, right? However, I can calculate my kinetic friction exactly, right? I can say that my kinetic friction is equal to the coefficient of kinetic friction multiplied by this n. And that's n is going to be our normal force. So you know everything has a force. Anytime there's every action has a reaction, sort of, right? So if I'm leaning on this wall, so long as I'm not falling through the wall, the wall is also exerting a force back on me equal to the force that I'm putting on this wall, allowing us to be in equilibrium, right? In that direction, meaning I'm not pushing through the wall. So that we're gonna find that normal force goes down, that's our gravitational force. Our normal force is pushing back up on the object, right? So anytime really you're touching something, you're gonna have a normal force produced on you. That's why we don't fall through chairs when we sit down on them. What else? Mass and weight. It's sort of easy for us to confuse mass and weight, right? Mass is due to inertia. Weight is sort of like weight. So basically, my mass would be given in kilograms, for example, right? But if I multiply that by gravity, I'll have a weight in newtons, right? That's how we can calculate our weight. Okay, cool. So I can say that my gravitational force, for example, right, is equal to m times g, and that g is gonna be constant, relative, it's constant, when it changes when you go to different parts of the earth and stuff, but it's gonna be, we take it as about 9.81. If you need to estimate, some people round it to 10. That might be cool, if you just need to do it off at the top of your head, but that's also how you overshoot the moon, so let's not overshoot the moon, okay? If you need to do quick calculations, 10 meters per second squared is a good value for g. Let me see. There's also something called center of mass. I might do a separate video on that. I'm not gonna talk too much about that, but basically I'm sure we've all seen that challenge of when you're supposed to you have a wall here, you bend, you try and lift up a chair, and it's harder for guys to lift it up, and maybe for gals it's not as hard. That's because the center of gravity for women most of the time is lower than for men, which makes it a little bit easier for them to pick up a chair. For men, it's a little bit higher. It's pretty cool. You should check it out. Maybe I'll upload a video of me trying it. But yeah, let's talk about acceleration. So acceleration is sort of the rate of change of velocity with respect to time, right? Acceleration is usually denoted with the letter A. Again, pretty intuitive. And that instantaneous acceleration is going to be given, of course, when this limit is going to 0. But if I have delta t, delta v, I'll just do that just to denote that it's a vector. That gives me my instantaneous acceleration, right? I'm gonna go ahead and just put I'll do that. Heck yeah, cool. Now if I want my average acceleration, sorry, I should have done this in green. I tried to do formulas in green, but if I want my average acceleration, I'm just gonna do that, and that gives me my average, right? Cool. Yeah, it's pretty straightforward. If this can be negative as well. Again, that just denotes deceleration, slowing down with time. Cool. Cool. I'm gonna go ahead and stop the video there. I just wanted to cover some basic concepts, acceleration, velocity, things like that. If anything was unclear, please go ahead and let me know in the comment section. I'll do my best to try and clear whatever doubts you might have and everything. Please don't forget to like and subscribe. Let's keep learning. Thanks.